Hi, me again. My earlier talk today was about my activities and the activities of human exploration, advanced exploration systems. I'm currently on detail, about 75% of my time, to assist in the Planetary Sciences Division setting up the Planetary Defense Coordination Office.
We have the presentation?
Yeah. Yes, they do. Okay. So my co-authors and I are all members at NASA headquarters of the PDCO. We're hosted and funded by Science Mission Directorate at this time. The office was established in January of this year to coordinate planetary defense-related activities across NASA and coordinate both U.S. interagency and international efforts and projects to address and plan response to the asteroid impact hazard. The organization seeks to lead national and international efforts to detect any potential for a significant impact of planet Earth by a natural object, appraise the range of potential effects by that possible impact, and develop strategies to mitigate the effects on human welfare. This is the current organizational structure of this organization. At any rate, from the NASA administrator down to the Planetary Sciences Division, Jim Green, the lead program executive or Planetary Defense Officer is Lindley Johnson. I'm sure many of you know him. And then this office also encompasses the existing NEO observation program. The program manager is Dr. Kelly Fast. The program scientist is Dr. Mike Kelly. You have to be a Kelly to get that job. And they manage things like the Minor Planet Center, the Center for NEO Studies at JPL, et cetera, and of course all the observatories that NASA funds. Interagency and emergency response is to develop the means, the mechanisms by which NASA will both communicate what may be happening and then work with the other agencies to mitigate the effects. And then we're also conducting mitigation research through the UN, through Same Page, and I'll explain all this later. Dan and Paul just mentioned the Asteroid Redirect Mission's ARM gravity tractor demonstration, and Jim Green talked about AIDA this morning and a few other projects that we're working on. So there are 3 steps to planetary defense: finding them, figuring out how serious the problem is, and working on mitigation opportunities. The NearEarth Observation, the NEO Observation Survey and Alert process is rigorous. It's also voluntary. The observatories worldwide participate in submitting their observations. They go through a series of quality assessments of the new observations to get a better idea of whether or not the trajectory that they've identified is indeed as worrisome as it might be, or no problem. So you correlate, you determine whether it's a potentially hazardous object. We say object because sometimes we don't know if it's a comet or an asteroid or a previously lost upper stage from a large rocket. We go through that several times to assess whether there's a potential impact. There are follow-on observations as soon as possible. If it does look like there's a potential impact, then there's a notification put out, and observatories worldwide voluntarily see what they can do. If we can get radar on it, we'll improve our knowledge of it quite dramatically, specifically about the orbit, and then those results are published. The alerts are sent to the Planetary Defense Office, the Minor Planet Center. JL, you want to raise your hand? Dr. Galacci is here. They post all this on the web for you to see, and they do a lot of the analysis. The JPL Center for NEO Studies does the hazard analysis and reports the potential for impacts, and they carry on the web a great deal of information about next observations, close approachers, and the NHATS target set, for example. But the characterization process is very important. We take these observations, initial detection, astrometry, and photometry, to figure out what the orbit is, how big it might be, okay, what it might be made of, like a carbonaceous chondrite. We try to get additional astronomy so that we can, astrometry, so that we can get a rough approximation of the rotation, the shape, the orbit, the size, and the mass. We need to do this when it becomes it listed as a potentially hazardous object, because it is mass, size, orbit that are key for starting a decision process on what we need to do in response to that. So this is a summary to give you an idea of why size matters. Okay, is because the NearEarth Observation Program was directed by Congress to find asteroids or objects above 1 kilometer in size. Now it's 140 meters. We've been working on this. We're a little bit late, behind congressional direction, mostly due to cost and weather. If you get a rainy season, then you don't get to see anything if you're working with a ground-based observatory. We declared victory on a certain sizes, on the larger objects, figuring that we had met the congressional requirement of 90% of the known objects. Of course, well, there was one discovered just this past week that looks like it might be 1.5 kilometers in size. So we're still filling in the gap. Is there? At any rate, so we're still looking to fill in this area here to get all these, okay? And you can see that by their sizes, it's estimated that they could go from continental to regional to city, that's the Tunguska, and then maybe not a devastation impact, but certainly worrisome enough or has the potential to cause damage to urban environments and to harm individuals. So this is why we care, and we work as hard as we can, as quickly as we can, to understand the threat that we may have detected. So what happens if there's a potentially hazardous object and we have some amount of warning? Now, the morning of February 15th, 2013, when the Chelyabinsk bolide blew up over in Russia, we didn't have any warning. So the phone calls that happened after that were, what just happened? type of calls, and who did that belong to? So it was quickly identified that it was a natural object, that it exploded in the atmosphere, but there were some worried phone calls. So now NASA actually has a policy on how these announcements will be made. With the Minor Planet Center, the JPL Center for Neo Studies, makes it a determination. They call the Planetary Defense Officer or the Watch Officer, who might be myself, or Kelly Fast, giving some basic parameters. What is the approximate orbital determination? Do we have any idea of size? So once that happens and we make a determination that we need to make an announcement, we let the NASA administrator know. And then the NASA administrator calls the Executive Office of the President, and the Executive Office of the President says, yes, I hear you. And then we start telling the other federal agencies who may play a role in a response. For example, Department of Homeland Security's Federal Emergency Management Agency. If the impact is in U.S. territory, FEMA steps up and leads the emergency response, and if it's outside the U.S., the Department of State notifies the affected parties. Now, one of the interesting parts about all this is all these assessments are basically done in public. All the data is on the web. You can go to the Minor Planet Center, and you can go to JPL, CNEOS, and you can find the data, look at the close approachers and stuff. So what it is NASA's job to do is ensure that the calculations are as good as we can get, that we have a clear, concise summary of the threat that we may be facing and what the parameters are. So that's kind of where we are right now in planning. And this is a NASA policy, and it's been signed off on up and above and beyond NASA. Now then, note, time taken to accomplish is directly proportional to time remaining to impact. So, maybe it's a telecon to the White House rather than the administrator. We don't ever expect to wake the president up, but he might want to know on his coffee that something's coming in 6 months or 3 years. The goal is to find them early so that we have an opportunity to do something about them. In conjunction with this, we're working with the United Nations Committee on Peaceful Uses of Outer Space. Action Team 14 has set up the International Asteroid Warning Network, which is a voluntary organization to allow data to go to the Minor Planet Center. So it's more observatories participating in the Minor Planet Center data recording every night. And then there is the Space Mission Planning Advisory Group. This is built on the idea that a response to an incoming asteroid would be better off internationally collaborated rather than a unilateral activity by any nation. So same page, and that is on purpose, you know, getting us all on that same page is critical. So they've only been convened about a year, so this group is just getting started. This is in 2015 worldwide coverage provided through the International Warning Network. It's been a great augmentation of the U.S. The U.S. is primarily in the southwestern United States and in Hawaii, okay, and you can see that we're able to augment that extensively. So then what happens? One of the first questions that the Federal Emergency Management Agency, or FEMA, came to us was, so what does it mean that it's 100 meters? What is it going to do? So we have some estimates, but we wanted to get a little bit better answers in the model. So we're funding here at Ames the Asteroid Threat Assessment Project, which looks at modeling airbursts, modeling impacts, understanding the effects of the atmosphere on the trajectory of the object, modeling breakup patterns, things like that. Am I out? Oh, no. Okay, I was talking slowly for once. Okay. All right, so they're developing a set of tools that we can model this to work in order to work with the rest of the government and being able to communicate what the potential threat is. You heard from Jim Green about AIDA, which is an ESA-NASA partnership, and DART, the Double Asteroid Redirection Test, in which we're going to aim a kinetic impactor at the orbiting companion of Didymos, which is a binary. Kinetic impactors represent a technologically achievable means to deflect an asteroid that's not too big, okay? We don't need to do advanced development of this one, and we think we understand the physics. The short warning hazard is looking at if we had a short warning or needed a high energy response, how we would model that, working with the Department of Energy, for example, and looking at what we might possibly do should something come along. But all of this together, it's not only finding them. Okay, we want to find them as early as possible so that we can possibly mount a deflection. Or if it's very large or not quite as much warning, it's disruption. But all along with all of that are modeling, decision-making, international, and communications. So to this end, we've set up two major interagency cooperation activities. One is with FEMA, the Planetary Impact Emergency Response Working Group, and one more slide after this, okay. PeerWig is looking at being able to communicate with the other agencies that work with FEMA exactly what an asteroid impact is going to look like. And the last one is called DAMIAN, Detecting and Mitigating the Impact of Earthbound Near-Earth Objects. How is that for an acronym? This is convened by the National Science and Technology Council to really bring high-level federal agency notification on what we might possibly do and how we might possibly develop and deploy a prevention mission. Think prevention. I'm proud to tell you that asteroids have been added to the United States National Risk List. So FEMA is now allowed to spend money on planning what we would do if there was an impact. Okay, so that was very quick. You can find out more on the web at nasa.gov/planetary defense. And I can take questions if you have any. So thank you. Can you translate it?
So what's FEMA doing? Because are they looking at how you'd communicate with the warning system. So you've got a good warning system, you've got good plans on how you might deflect or what, but what do you think about, are they looking already at evacuations and risk corridors and things like that in terms of the public warning?
Yes. So what we're also trying to do is establish when you would, what kind of response is required. So a better understanding provided by NASA of what an impact corridors, you know, the asteroid comes in, if we have any uncertainty, we don't know where it's going to impact and how we go about refining that. So they're pretty much rejecting the concept of the Torino scale, which is a hazard assessment, and into more like a hurricane warning approach.